Hello everyone. I'm Jonghoon Lee. I'm TA for serial 9, 901, and 902. I hope everyone are staying safe and doing well. Uh, I am sorry about this circumstance. Unfortunately, we need to change our live session into the virtual meeting. Uh, I promise I and Kostanka, the TA, we will do our best to help you. So if you have any concerns or any issues to want to discuss with us, please email us and we will reply you and contact you as soon as possible. So there are a few things I need to notice. First of all, we've decided to have a live session together. So this week I will do the live session. The next week, the other TA, Kostanja, will do the live session. Okay. So uh, this is, but we prepare the live session together. So if you have any question about it, then both of us uh, are prepared to discuss about any question about live session or class. So please contact us. And then, okay. So one other thing is about grade. So we are not supposed to let you know your grade on the email. So we will not send a grade through email. But if you want to know, please assign a meeting, the Zoom meeting with us, or you can contact with us in the office hours. Then we will share your grade to you. And uh, so, yeah, let's go to the lab today. Okay. Yes. So this is the first time I record the rec session in the Zoom. So please forgive me if I have uh, any technical problem. I will learn how to do it, uh, and I will be prepared for the next time. I hope we do not have any issues today as well. So today we will discuss about the multiple regression, and we will recap the bivariate regression, and I also will introduce what is the multiple regression and why we need this, and and explain the difference between bivariate and multiple regression. So before going further, there are a few business things that I need to notice to you. So first one is about the problem set 4. We have uploaded the problem set 4 in the eCampus. So please find the problem set 4 on the eCampus, and please do not forget you need to submit your problem set 4. Due is April 6th. And so we changed the submission by email to TA. I had one issue. So right now, we've received your problems at 3, but when you do email, please email me with you. Please set your file name as your name and the the name of the homework. Like this one is a Jonghoon dot dash and problem support, something like that. It would be much easier for us to download and grade your papers. And also, you need to submit your rough draft until April 8th. So please do not forget. And if you have any questions about both of the homeworks, please contact us. We will help you to do these things. If I have finished to grade the data description, I'm right now sending an email about the comments of the data description, but I have not finished it yet because I'm sorry, and because there are too many students, I need to send the grade, so it's kind of slow. But for now, I've sent emails some of students who who should have a discuss with me. So if you do not receive any email from me about the data description, then please consider it as you are okay for now. And so yeah. And if you have any question about your data description or grade, please email me and contact me. So there are a few things I want to cover about the data description. So first one, this is the most important thing. We need to have our own data. If you do not have your own data yet, please contact TA as soon as possible, because you need your own data, because we require to run regression analysis in your paper. So if you do not have your own data, then it is impossible to run your own analysis. So please remind that it is required to have your own data. And so the another thing is about the data structure. So some of students may have a problem about building a data structure. This is because sometimes we can have a difficulty to understand what is our unit of analysis or level of analysis, but the data structure highly depending on the unit and level of analysis. So it is important to understand what is my unit and level of analysis. So for example, if I want to study about the relationship between political preference and their religiosity, then it is highly likely my unit of analysis is the individual. So what it means, if my question is like, if I have a religiosity, then what my political preference would be. This is the question about an individual, a person. But sometimes you might wonder about the relationship between of nation or of a state. And then the level, the unit is not an individual, but it would be a nation or a bigger unit than an individual. So please keep in mind what is a unit for your analysis. Then depending on the unit and level of analysis, it determines what your observation would be. If I have an individual level of analysis, then my observation should be for an individual. But if I have a unit of analysis as a nation, then my level and my observation in the data structure should be one nation. Okay. Okay. Give me a moment. No. Okay. So another thing, some of students have not merged their data set yet. If you merge your data set as a one file, so please do that. Merging the data set means if you have two different data sets, first one is about your independent variable, and second one is about your dependent variable, then please combine it together. We've introduced how to merge the data set before. So if you do not know how to do it, then you can check the R script in the lab session 6 or 8. Then you can find how to do it. If you still have a problem, then please contact us. And the content of the paper. So you need to submit your own rough draft. So I will introduce what the rough draft should have, what kinds of the content. So first, introduction. Second, in the introduction, you will explain briefly what is your question, what is your argument, and explain your method and explain your result. And the literature review. So in the literature review, you will explain what the previous research have done and what is the difference between your own paper and the previous literature. And the theory section. So in the theory, you will introduce some of your arguments about how do you think the relationship between your independent and dependent variable, and why do you think like that? And suggest a hypothesis. The hypothesis is a little bit different with your argument. In terms of the hypothesis, it can be testable. So the hypothesis will be related to the method and your regression analysis and the results. So in the method, you will explain your data set and your measurements and maybe summary statistics. And in the result section, we will present the result of the regression analysis and conclude it. So this is the brief of what kinds of the content your paper should have. But if you want to have more details, then you can check your syllabus, or we downloaded some rubric on the eCampus that guide you how to write in your paper. So please use that and read it. So today's lab, we will talk about bivariate regression and multiple regression. We've introduced bivariate regression before the spring break, but time has passed. So I will recap it, and I will introduce multiple regression, and I explain what is the difference between bivariate and multiple regression. Let's go to it. Okay. So I hope you can see the RStudio here, and give me a moment. I will let. Okay. Stop sharing. Okay. So what we will do for this lab, that is, I introduce some multiple regression, then let's talk about it. So raise your data set first, the global environment, and this is two required packages for today's lab. The math is for the function we will use in the future, and the package of the knit-r is for making a nice table. So today we will not use any data set, but instead of that, we will generate some hypothetical data, and we will talk about regression analysis by using those hypothetical data sets. So to generate hypothetical variables, we need to set a seed. Then for the bivariate regression, we set the number of observations as a 50. And we will make a hypothetical data, which is a x and y1. And the x and y1 will be related with each other by using this equation. So let me introduce it step by step. So I first generate 50 data points of x, which has mean as a 0 and standard deviation as a 3. So the data of x, our independent variable, has a mean of is supposed to have a mean of 0 and standard deviation of 3, and the number of observations would be 50. And also, I will generate some error term. This is about the stochastic term that affect the relationship between y and x. And I set the intercept as 3, and the effect of the independent variable on dependent variable as a 2. Then right now you can see we have x and beta at a turn intercept, but no y. So I will generate our dependent variable like this. Now we have y and x. So, however, this is the data generating process. So it means in the real, the data generating process means how our data be generated. In this case, y is generated by depending on x, the values of x, and the error term. And so, okay, let me introduce it again. So in the reality, we do not know actually how the data generated, how the data are generated, but in the R, we can do some experiments. Like we made a hypothetical data, which is x and y, and we can set there is a relationship between x and y, like this equation, and we pretend that we do not know how x and y related. In this case, we do not know what the actual effect of x on y, but and we pretend we just have the data of this. What is this? So we will pretend we have a data set which has a variable y and x. Y is our dependent variable we want to explain, and x is our independent variable. Then we actually do not know, we pretend we do not know how what is the effect of x on y. Then we will estimate it by using linear regression. Okay. So first, we can visualize it. We plot the data x and y. Then we can see there might be it seems like both variables have a positive relationship like this. But so the red line means the slope of the red line means the effect of x on y, and the sparseness around the red line. So how much the data points spread around the regression line means the effect of the error term. So if you have a larger variance in error term, so in this case, we will use different error term. Previously, the standard deviation was 1 in the error term 1, but in the error term 2, the standard deviation becomes 3, which is larger than before. Then the new data of y2, and the points become more sparse, right? So the data point is widely sparse. If we have a larger variance in error term. Okay, so the next thing we can do linear regression. This is the function of the linear regression analysis. So I will do linear regression. I regress y on x, and I will use the data, which is data 1. Okay. Then I will save those results to the model 1. Okay. Then do it. And we can extract. So after saving the result, we can see the result of the regression analysis by using the function of summary. Then we can see what is the estimated coefficient, and what is the standard deviation, and what is the t-value, and r squared, like this. But sometimes this table is not that easier to observe. Then we can make a nice, much nicer table by using these codes. So first, we will extract the estimate value of the coefficient, in this case this and that, by using this code, and we will save it as an output 1 and make a table by using output 1. Then we will have a much nicer table. Okay, so the linear regression analysis says that gives us the result of the coefficient. The estimate value of the coefficient is almost 2, and the intercept is 2.8, something like that. So the previous setting for true value of the parameter was b was a 2, and intercept was a 3. So the linear regression analysis pretty good job. And as we learned before, the beta, the coefficient is estimated by the covariance between y and x over variance x. So if we run this code, then we should see the result of this code should be equal to this estimate value of the coefficient. Okay, let's see. Yeah, we have almost same value, exactly same value. Then we can also see how the R square is calculated. So R square means R square means the proportion of the variance in the dependent variable that is explained by the variance in independent variable. So in other words, R square means how well the independent variable explains the dependent variable. Okay, so the way to calculate the R square is like this. The R square would be the explained variance in the dependent variable over the whole variance in the dependent variable. But so first, we extract the residuals, which is first of all, the residuals is the difference between actual data point and the fitted value. So in this graph, the residual of this point would be the distance from this data point to this line, okay? We will extract every residual for every point by using this code. In this code, from the result of the linear regression, which we saved this as a model 1. From that, we will extract the residuals. So we can see after we saving the result of the linear regression, there are some results that we can extract from it. Then we can see what we can use by using $sign. Then the $sign gives you those results. Then what we need for this is a residuals. Then we will have it. Each value means the residual of each data point. So in other words, each value represents the difference between the actual data point and the fitted value. So we will say these residuals to the RES, and we will take square of each of the residuals, and we will take the sum for every residual squared. Then we will save as a SSR. It means the variance in the dependent variable that cannot be explained by independent variable. So think about it. The independent variable, the explained part by independent variable is represented as a regression line, the fitted value. But the difference between actual data point and the regression line means the last part of dependent variable that cannot be explained by independent variable. You got it? So we will save this, and this is the whole variance in the dependent variable. So that is not such a difficult. So see, this is one observation of y. So each observation, and this is the mean of the y, and we will take the difference between actual data y, actual value of the y, and the mean of y, and take the square and sum. This is the definition of the variation. So this is the variance of dependent variable. And R square can be calculated by this. Then let me see. So it's saying R square is 0.97. So this model, this linear regression model, explains a lot of variance of independent variable, like 90-70%. And if you see the result, it's saying, see, we have same result. So we did our job well. But if you have a larger outcome, then it means there are much more proportion of dependent variable that cannot be explained by independent variable because the outcome is not related with the independent variable. So the influence of outcome on dependent variable cannot be explained by independent variable. So if you have a larger error term, then it means the proportion that of dependent variable that cannot be explained by independent variable become larger. So we will see our R squared will be decreased. Okay. So remember, in the data two, we have a larger variance in error term, right? So the result of the linear regression in data two should have a higher variance in residuals, right? Then the R squared will is smaller than the model one because we have a larger variance in residuals, right? So yeah, so the reason R squared is a smaller for model 2 than model 1 because we have higher variation in error term. It leads to higher variation in residuals either. And because of that, the proportion of the variation in dependent variable that cannot be explained by independent variable become larger. So we have smaller R squares. Okay. For now, we recap the linear regression, and I believe we almost have 15 minutes. Maybe not. I actually forgot to count the time, so I suppose that we have 15 minutes. I hope so. So for now, I will introduce the multiple regression. The biggest difference, so the main difference between bivariate and multiple regression is number of independent variables. So bivariate regression, we just include one independent variable, but in the multiple regression, we include more than two independent variables. So this is the biggest difference. And give me a moment. So why we need to do that? So the question is why we need multiple regression instead of a bivariate regression. The answer is omitted variable bias. So in other words, if we do not include the some variables, then our linear regression analysis would have a bias, would be biased. So that is why we need to include every variable that we think it might cause the variation in our dependent variable. So let me introduce it more. In this case, we will do experiment and we set the number of observation as a 300, and we will generate two axes to x by using this code like this. We have this should x1 and x2, and so this is the function MV norm, this MVR norm. This is different what we used previously. The biggest difference of this function is we can generate two random variables together, and we can set the covariance by using this matrix. So in this case, what we did before, we usually set the standard deviation of just one variable, but instead of that, in this MVR norm function, we set the covariance matrix by using this condition. And the covariance matrix means, first one, the 1 is a variance of the x1, and second covariance x1 and the 0.6 is a covariance of x1 and x2, and 0.6 is also covariance x1 and x2, and 2 is a variance of x2. So if this function works nicely, then we can see the covariance x1 and x2 is closer to the 0.6, and variance of, oh my god, nope, what's going on? Sorry about it. That is one technical issue. So yeah, I'm sorry about it. So what we did before, where were we? Let me see. Okay, so this is the covariance matrix. So if the function works nicely, then we can see the covariance between x1 and x2 is closer to 0.6. It's not 0.6, but closer to. And the variance of x1 is closer to 1, and the variance of x2 is closer to 2, right? So it does pretty nice job, the function. And it means we have two independent variables that related to each other, right? So as if we can see, the correlation between x1 and x2 is not equal to 0, which means they are correlated with together. And we set our dependent variable is related to both independent variables. In this case, the intercept is a -2, and the beta 1 is equal to 1, and beta 2 is -3, and we have a error term as mean is 0 and standard deviation as a 4. So let's make new y. Give me a moment. Yeah, much more clear. Then this is the data set. So remember, in the reality, in your in your research, you do not know the exact equation, the exact data generating process, which cause the variation in your independent and dependent variable of interest. So the data set you should have right now is kind of like this. So for your research, you have your own data set like this. You have a plenty number of observations, and each observation has the information of your independent variable. No, this is dependent variable. The dependent variable and independent variable and maybe control variables, right? So please let us know. Please let your TAs know if you do not have your own data set like this, or if you have something different data structure, then please let us know, and we will help you to you will become on a track. Okay. Okay. So I don't know how much the time is left. I think I do not have much time. So, okay. So this is the data frame we will have in the reality, and the visualization. So in this case, this plotting is just for bivariate relationship between y and x1. And if we, as you can see in the plot, even though we make the y as a related be related to the x, in the bivariate plotting, we cannot see there is kind of a relationship between x and y, x1 and y. So if you do just bivariate regression, which means just regress y on just x1, then you will have a weird result. See, like this. So in this case, the estimate value of the coefficient for x1 is minus 0.5, and even this is not statistically significant in the significance level of 95. So it means this refers to the omitted variable bias. So in other words, because you omitted the variable of x2, okay, in this linear regression, so the omission caused the bias result in your estimation. The estimated coefficient should be closer to 1, which is the original set of the true value of the parameter, but it is not. So if you see, when we do for linear regression, y and x2, then we also, no, sorry about it. We can also see, oh, see, we can also see x2, the estimate coefficient is it's kind of closer to 3, -3, but it is a little bit different. So the bias for x2 is lower than the previous one. This is because okay, here. The bias is because of the beta 2 and the correlation between x1 and x2 like this. The uh, the estimate coefficient of the beta 1 when we omit a variable is be composed of two terms. First one is about the actual value of beta 1, and the second one is about the value of the beta 2 times the correlation between x1 and x2. But like this, in this case, so for the x1, this would be larger because beta 2 is larger. Okay. And then, so what we see right now, if we omit some variable, then the bivariate regression could be biased, right? The way to deal with this problem is just include the variable and do multiple regression. So in this case, we do good model, which is the linear regression that regress y on both x1 and x2, right? Then the output of the linear regression is much better than before. See, the estimate value of the coefficient of x1 becomes 1.07, which is really closer to 1, and also statistically significant, right? And the x2 is closer to 3, -3. So if we compare this result with another just for bivariate regression results, we can see this is much improved. X1, when we do just bivariate regression for X1, we can see the estimate result say there might be a negative relationship between X and Y, but which was not, which was totally not. So like, so we need to do multiple regression for not face omitted variable bias. But sometimes the omitted variable bias does not matter when the relationship between two independent variables is there has no relationship between two independent variables. So below, this is the practice for when the omitted variable bias does not matter. So I think I believe I use more time. So I finish the last session today here, and I strongly recommend you do this practice as on your own. You can just click Control Enter for each line of the code. Then you can see this kind of the table. Then please interpret, please think about why omitted variable bias does not matter in this case and what it means, and why can you explain why Does that matter? And yeah, so I'm sorry again. I think I may use more time than I need to, than I should do. And please let me know if you have any other concerns or suggestions or questions about the lab or class or your grade, and please email me. And please forgive me the late response because my email box is out of the explosion. So yeah, I I thank you very much, and I hope you are doing well and staying safe. See you.